We're still doing law of cosines on page 11. In case you didn't remember, though, look at this triangle here and see what you know. You know the three sides. You don't know any angles. Well, remember, with law of sines, you have to know one angle side pair, and you don't know any here. So you're definitely not going to use law of sines. Okay? Since you're missing the angle information, you're going to use this version of law of cosines, which has a fraction with b squared blah 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 on top and 2bc on the bottom. Okay, this is all set up so that you can figure out angle A without much algebra. So for b squared we're going to put oh, and look what we did. We are going to rewrite this equation because the angle we don't know is angle B, but they have angle A here. So we're going to switch all of our A information, we're going to switch to B. All of our B information, we're going to switch to A. So we're going to put cosine of big B is equal to A squared minus C squared minus B squared. And then on the bottom, we're going to have 2AC. Oh, this should be plus, right? Okay. Now, cosine of B we don't know. It's equal to A squared, which is 15 squared, plus C squared, which is, and I just marked this one wrong, this would be 8 squared, minus B squared, which is 10 squared. And then 2 times 15 times C, which is 8. Okay. Now we just need to put this in the calculator. So 15 squared, and I would do the numerator and the denominator separate because I know that sometimes we have trouble with our parentheses. I mean, if you do all this in parentheses and then divide it by the denominator, there's no problem, but usually we forget to do that. So let's just do the numerator first and get 189. And then we'll do the denominator, which is 2 times 15 times 8. I think maybe we could do this in our head. 2 times 15 is 30. 30 times 8 is 240. Okay, so now 189 divided by 240. 0.7875. Okay, so the cosine of B would be 788. Okay, so what would B equal? We just need to find the inverse cosine of that. Inverse cosine of that. 38 degrees. And that looks reasonable, right? 38 degrees for that angle. All right, moving on to the last easy one. Okay, so what do we know? We know this. We know this. We know this. Again, we know three sides. We don't know any angles, so definitely not law of sines. We're going to use this equation here, but maybe we need to rewrite it because they got x's and they got z's. Let's see. So what do we know? Well, look at that. They put an a for us there. It's kind of strange. Small a. Usually small a is reserved for. Sides. So put big A, small b, small c. Okay, and so we can use this equation as is. So the cosine of A is equal to b squared 112 squared, c squared, which is 123 squared, minus a squared, which is 100 squared. And then we divide by 2bc. So 2 times 112 times 123. Okay. So we'll do the top part. 112 squared plus 123 squared minus 100 squared. We get 17673. 17673. Now in the denominator we'll have 2 times 112 times 123. And we get 27,552. Okay. Then we're going to divide those. This divided by that. And we get 0.641. You should always get a number between, 0 and 1 or -1 and 1 for cosine and sine. Otherwise, something is definitely wrong. Okay, now we're going to find the inverse cosine of this. Inverse cosine. Then you just have a math error if you don't get a number between 0 and 1. 50 degrees, so A is 50 degrees. 50.1 degrees. Okay, and that looks reasonable. Okay, moving on. Now this is a word problem. In triangle ABC, CB is 120, AB is 115, and B is 110 degrees. Okay, so this must be B. Okay, something like that. Sorry I didn't do that clockwise, but they say you're supposed to do that, but in the end, the triangle angles and sides are the same. Find the length of side AC. And you can see that this triangle, we don't have any angle and opposite side pairs, so obviously we're not going to use law of cosine, so that means we're going to be using law of sines. And the angle that we know is angle B, okay? So our equation needs to have the cosine of B in it, okay? So we're going to use the regular form because we're looking for a side, so we'll use the form a squared equals b squared plus c squared minus 2bc cosine a, except we're going to change all of our a's, right? Because the angle that we know is angle B, and we're looking for small b. So we're going to change our a's to b's. A's to b's. Okay? And then we're going to change our b's to a's. Okay? And then it'll be the way we want. B squared equals a squared plus c squared. The c's can stay the same. Cosine b. Okay. Okay, so now we just put in the numbers. So b squared we don't know. A squared is A, that's B. So A squared would be 120 squared. C squared would be, this is C. C squared is 115 squared minus 2 times 120 times 115 times the cosine of big B, which is 110. So the only part that we're going to do here is I'm going to do the cosine of 110. Cosine of 110. That gives me negative 0.342. Okay. Now don't be scared that that's a negative number. Do you see how the negative here? It's gonna all work out. Okay. So the rest of it stays the same. We could we're gonna use the offline calculator because it's faster. 120 squared is 14,400. 115 squared, 13,225. 120 times 115 times 2, 27,600, which is times 0.342. It's a positive 9439. Okay. So 9439 plus 13,225 plus 14,400 is 37,064. So B squared equals 37,064. And then we take the square root of both sides and we get 192. 193 actually. Okay, so side B is 193. That looks reasonable. The sides are 100 something. Okay, moving on. XYZ, triangle XYZ. XZ is 12, XY is 8, and YZ is 10. Find the angle side X. Okay, so again, this is going to be law of cosines because you know all three sides, and you're looking for an angle. And the angle you're looking for is big X. So let's name this small x, and we'll name this small y, and we'll name this small z. And now, instead of writing it as, and we want to know the angle, so we want to use this form here. Okay, but we're gonna change a lot of these variables because it's x, y, z instead, right? Okay. Okay, so now instead of cosine A, we're going to have cosine X. And instead of B and C, we're going to have Y and Z. Okay, so let's change them all. We're going to have cosine of big X is equal to Y squared plus Z squared minus X squared all over 2YZ. You see the pattern there? Okay. So cosine x is going to be equal to y squared, which is 12 squared, and z is going to be 8, and then we're going to square that, and then x is going to be 10, and we're going to square that, and we're going to divide by 2 times 12 times 8. And you just do that algebra, and you're going to get a value for cosine x, and then you're going to take the inverse cosine of that to get you're going to take the inverse cosine of that number to get the angle x. Okay? I won't work through that all the way through the end. You can do it. Okay, Allison, Jane, and Stephen are together at point A. Okay? Jane walks 12 meters due south from A. Okay, so we're at A, and we're going to walk due south, which is down. Reaches point J. Stephen looks at Jane, turns through 110 degrees and walks 8 meters from A and reaches point S. Okay, so due south, Stephen looks at Jane. Okay, so only Jane walked to point J, right? Stephen is still at point A. So he looks at Jane and then he turns 110 degrees. Okay, so we could say that he starts here where he's going to turn 110 degrees, 110, and then he's going to walk 8 meters and reaches point S. Okay. 8 meters. Represent this information. Okay, we just did. Some of you might say, you know, like, well, he doesn't say if it turns left or right, but actually either way you do it, you're going to come out with the same answer probably. Okay, and then they're asking, how far is Stephen from Jane? So what we want to know, what we do know is this, and we know this, and we know that Jane will walk 12, so we know this, right? And they want to know this side here that we don't know yet. Okay, so obviously law of cosines because we don't have any opposite angle side pairs. Okay, and they want to know how far SJ is. Okay, so let's rename these. Well, we'll just rewrite the cosine formula. Okay, so we want to rewrite a squared equals b squared plus c squared minus 2bc cosine of a. Okay, we're going to rewrite this. Instead of a, we're going to use, no, well, a, we're going to use a, that's fine. Instead of b, we'll use j. Instead of c, we'll use s. Js cosine of a. So cosine of a is going to be a cosine of 110. J is going to be, side j is going to be 8 squared, right? Because that's the opposite off of vertex j. This is going to be j. This is going to be s. Okay? So, and s is going to be 12 squared, and then minus 2 times 8 times 12. cosine of 110. Okay, and so cosine of 110, I think we've seen that before. It's going to be negative 0.342. Yeah, we just saw it, I think. Okay, and then if we multiply this out, it's going to be 192 or something like that. Okay, 12 squared 144, 8 squared 64. Okay, you're going to add all that up, and then you're going to take the square root, and that's going to be your answer. Okay, and then it says find how far north Stephen is from Allison. So that is a interesting problem. To do that, I mean, what they want to know here is they want to know, okay, if you draw a little triangle like this, like here's the original triangle SAJ. They're saying now, what is this length here? How far north is Stephen from Allison? Okay, so this triangle, you know that this side is 8, and you know that this angle here, it's not 110, right? It's 110 minus 90, so it's actually 20 degrees here. Okay, and then you want to know the north-south side. How long is that? So here it's actually just like a simple trig relationship. You're going to relate this angle with the opposite side and the hypotenuse. So opposite side hypotenuse, that would be sine. So you're going to have sine of 20 is equal to the opposite side divided by the hypotenuse 8. Okay? Sine of 20. Let's see. Sine of 20. 0.342. 0.342 times 8 equals A. Okay? So that would be how far north Stephen is from Allison. And that's it for this page.